Welcome to the class of antenna and wave propagation. Here we will start with the electrostatistics. Now, the first topic of the today's lecture will be the Coulombs law and the electric field intensity. So, first is the Coulombs law. Coulombs law states that the force between the 2-point charges, that is Q1 and Q2, will be directly proportional to the product of Q1 and Q2 and inversely proportional to the square of the distance between them. Now, before we start with the Coulombs law, we will just see that this one, we have already studied that there is a matter, and the matter, now if I further subdivided the matter into two parts, that will be the molecule, and then there will be a subdivision, that will be atom, and in the atom you will see here that this is a nucleus. You will see in the atom, you will see that electrons and protons and the neutrons. So electron and proton, this electron is a negative charge and this proton is a positive charge, and this neutron does not have any charge. So we are talking about this point charges. This may be negative charge and this may be a positive charge. Now if I say that there is a 2-point charges are there. First is this one, which is defined by Q1, and second charge is this one, which is denoted by Q2. So if this charge will be positive and this charge will be negative, so there will be a force of attraction between them, and if both charges are same, it is positive or negative, then there will be no force of attraction, there will be a force of repulsion. The force between, I can say force between the 2-point charges, that is Q1, Q2, will be directly proportional to the product of Q1, Q2 and inversely proportional to the square of the distance between them. Then if I say the distance between these 2-point charges is R, then I can say the force is inversely proportional to R square, and force will be directly proportional to Q1 and Q2. Clear? And the first condition is that these 2-point charges should join along a same line. Clear? Then force, then you will see that this force is Q1 Q2 divided by R square. Now if I remove the proportional sign, you will get F equal to K into Q1 multiply Q2 divided by R square. Now what is K? K is what? 1 upon 4 pi epsilon. K is equal to 1 upon 4 pi epsilon, and this epsilon is a what? Permittivity of the free space, or you can say, if I say this is a material, the point charges in the material, then I can say the permittivity of the material. Clear? So this F, then the F will be equal to Q1 Q2 upon 4 pi epsilon naught divided by R square, and this epsilon naught is equal to have a constant value, that is 8.854 multiply में 10 के minus 12 Coulomb square per Newton meter square or Farad per meter. Now if I say the point charge q1 is there, and this is point charge q2, and this one is the origin. And from the origin I am standing here at this point, and one point charge is there q1 in the space, and another point charge q2 is in the space. So the distance vector from origin to q1, that is denoted by r1, and this distance vector, that is r2, from origin to q2. And the distance between the q1 and q2, that is a distance vector, that is r12 from 1 to 2 point, from 1 to 2 point. Now if I say this q1 is applying some force on q2, then if q1 is applying some force on q2, then the force will be in this direction, and that is denoted by F12. Now maybe there will be some force q2 will apply on q1, then the force direction will be in this, that is F21, that is force on q1 due to q2. Clear? Now you will see there, see that if I want to calculate F12, then F12 will be what? Equal to what? q1 multiply में q2 divided by 4 pi epsilon naught multiply में r square, that is r12, multiply में unit vector will in this direction, that is a cap r12. Clear? Now if I say what is the unit vector, we have already studied that a cap unit vector is equal to what? Will be what? Vector divided by its magnitude. Clear? Now just put this value, you will get this one q1 q2 upon में 4 pi epsilon naught r12 multiply में r cap 12 divided by, so you will see that this will become equal to what? This will become equal to 1 upon में 4 pi epsilon naught multiply में q1 q2 divided by की पावर में 3, and this is what? R12 is what? This R12 vector is what? Is equal to distance vector R2 minus में R1. So I can say that this one will become equal to q1 q2 multiply में R2 vector minus में R1 vector divided by 4 pi epsilon naught R2 minus में R1 की whole power में 3. So you will get this one. Clear? Now if I want to calculate F21, now you will see here F21 will be what? F21 will be what? q1 q2 will be equal to r1 vector minus में r2 vector divided by 4 pi epsilon naught bracket start r1 minus में r2 की पावर में 3. Clear? Now so you will see here that F21 will be q1 q2 r2 minus में r1 minus r2 divided by 4 pi epsilon naught r1 minus में r2 की पावर में 3. See, now you will see here that this is what? F12 and this one is F21. You will see that, you will observe that F21 will be negative of F12. So F1 vector F12 minus में F21. This shows this proof also prove the Newton's third law, that the force on each charge have equal magnitude but opposite direction. Clear? Now next one is the principle of superposition. Principle of superposition states it is used when their number of point charges are there, and the net force on one particle due to all other charges will be equal to what? It will be equal to the vector sum of each force due to the individual charge, and each individual contribution is unaffected by the presence of other charges. Now if I say, let's say if I say one charge is there, this is another charge, this is another charge, and this one is another charge, that is denoted by F1, F2, F3, F4. Clear? And one point charges will be there. Let's say this one is the point charge, that is noted by 0. So if I say the net force on this charge, net force on this charge due to all other charges will be equal to what? F10 plus में F20 plus में F30 plus में F40. So these all charges will apply some force on this one. So this superposition principle states that the total force applied on this point charge 0 will be equal to the vector sum of each force due to the individual charges, and each individual contribution charges will not affect the other force, that will be F10 plus में F20. Similarly, now I can say that what will be the F10? F10 will be what? This is Q0. If I say this has a point charge Q1, Q2, Q3, Q4, and this has charge Q0. Clear? So F10 will be equal to Q0. These are the charges 1, 2, 3, 4, and this one is point charge, that is Q0. So this has a charge Q0, Q1, Q2, Q3, Q4. Clear? Now these all charge applying some force on this charge, and the total force on charge 0 due to all these charges, and if I say that will be equal to F10 plus में F20 plus में F30 plus में F40. Clear? So F10 will be equal to Q0, Q1, R minus में R1. What is this R minus में R1? If I say this is the origin, this is the origin, so this will be what? If I say this is the origin, this will be what? R0, and this distance will be R1. Clear? So R0 minus में R1 divided by R0 minus में R1 का whole power cube. Similarly for F20, Q0 into में Q2 R0, this distance R2, R0 minus में R2 upon 4 pi epsilon R0 minus में R2 का whole cube. Similarly, if I say these are the n point charges are there, so that will be Q0 into में Q1 R minus में Rn upon 4 pi epsilon R minus में Rn की power में 3. Now you will get what? Overall general formula will be what? Overall general formula will be what? F equal to Q naught upon 4 pi epsilon naught summation K will vary from 1 to n, Q के R माइनस में R नॉट माइनस में R के अपॉन में R नॉट माइनस में R के की पावर में 3. Clear? These are the vector. This is a vector quantity. This is a vector. Remember. Now next one is the electric field intensity. What does this electric field intensity? This electric field intensity defines the force per unit charge, that is E equal to limit Q approaches to 0 F divided by Q. Now if I say this is a point charge and these are the charges which is applying on some force. So electric field intensity at this point charge will be equal to force per unit volume. If I say this is F1, F2, this is third and this one is fourth. So F vector on charge 4 will be what? Plus में F2 4, F3 4 will be equal to what? Let's say this one is F4 N. Clear? So at this point electric field intensity at this point will be what? Force per unit charge, that is F N4 divided by Q. Q is the what? Point charge at this point. यानी कि electric field at this point, point 4 will be equal to Fn4 divided by Q4. That is the electric field intensity. So electric field intensity is equal to E divided by F by Q. These are all the vector quantity. Clear? So unit for E will be equal to Newton per Coulomb or volt per meter. So electric field intensity at point R due to point P, charge located R dash is readily obtained by this one. So for general formula, I can say that. So this one was the general formula. This was the formula of force, that is equal to Q1 Q2 upon में 4 pi epsilon naught R square A cap R. So this was the formula for force. So you will see that now just see this one. I can say that Q1 Q2 A cap, sorry, this one was A cap R, R square, and this one's R vector की power में R. Clear? Now if I say the electric field at point Q, at point Q1, electric field at point Q1 will be equal to what? Q2 into में R vector divided by 4 pi epsilon naught this one, and this R vector will be what? This R vector will be what? Distance vector, that will be equal to R minus में R dash. Clear? Now next one is the electric field for 2-point charges. What is this electric field for 2-point charges? Now if I say 1-point charge, this one is point charge Q2 in the space, and this one is point charge at this, that is Q1, and I want to calculate the electric field at point P. I want to calculate the electric field at point P. So I think we should know the point charge at point P for calculating the electric field. Clear? Now first I will calculate the force at this point P. Force, I will just first calculate the force at this point P due to point charge Q1 plus में force at point P due to charge Q2 will be equal to what? Now if I say this one has a point charge Q3, so then you will see that overall force at point P will be equal to Q1 Q3 upon में 4 pi epsilon naught R वेक्टर माइनस में R1 डिवाइडेड बाय R वेक्टर माइनस में R1 की पावर में 3. क्लियर? दैट इज ड्यू टू पॉइंट 1 प्लस में फोर्स ड्यू टू पॉइंट P2 विल बी व्हाट? Q2 Q3 अपॉन में 4 पाई एप्सिलॉन नॉट R वेक्टर माइनस में R2 की पावर का मैग्नीट्यूड की पावर में 3 डिवाइड बाय मल्टीप्लाई में R वेक्टर माइनस में R3. Clear? Now we will see that now I want to calculate the force electric field at point P. At point P will be equal to force at point P divided by Q3. Then you will get this one. Clear? So electric field intensity at point R due to n, similarly for n point charges, that will be equal to electric field is equal to due to n point charge 1 by 4 pi epsilon naught k equal to 1 to infinity qk. These are number of point charges, that is n point charges r minus my rk divided by this one. So the books I have referred for preparing the slide, that is Principle Electromagnetics by Sadico. Thank you.